So let's say this is the nucleus of the atom for which you are making a balloon model today. Okay? This is the nucleus. Okay? So out of the nucleus, as we go work our way out from the nucleus, okay, what's the first sublevel we come to? Well, hydrogen represents an electron in that first sublevel. What is that first sublevel? It's 1 is the primary level. What's the sublevel? S. Okay? So this is the nucleus. Pay attention. There's the 1s sublevel. Okay? So this is the 1s sublevel. Okay? Now then, after we fill up the 1s sublevel, we actually fill up the 2s sublevel next, right? But in terms of where we go from the center out, we actually reach the p orbitals next. So here's our 1s sublevel, and you can see how 1s fits inside 2p. So these are the 2p orbitals. Okay? So nucleus, 1s, and 2p. And then around 2p is the 2s sublevel. Okay? Now that doesn't mean we fill 2p before 2s. It means that we just kind of encounter that first. All right? So nucleus, 1s sublevel, 2p orbitals, 2s sublevel. Okay? You don't have a 2s sublevel or a 1s sublevel in your model. However, what you do have in your model are dotted lines. That is, when I say in your model, I'm talking about the balloon models that students make in this class. You have a dotted line right here. Okay? That dotted line right there shows where the outer edges of the 1s sublevel is located. Does that make sense? Okay? So that dotted line would fit right here. Now, what this also means is that the actual shape of the orbital isn't a double balloon. We often think about it that way because it's a lot easier for people, students, anybody to think of a shape of a double balloon than the actual shape of an orbital. But the actual shape of that p orbital are like the two ends of the balloon sitting up in space. That makes sense? And that's why you have that dotted line around your balloon, because it shows where the 2p orbital or any p orbital actually stops. They're not really connected. Now that's not to say they are sort of connected. Let me be careful about that, because when you get to college, I don't want you to tell some professor, Mr. Tatterhead, don't do that. Okay? The fact is they're connected, but not in a way that we actually think about in normal understanding of connection. In fact, what happens is electrons go back and forth between this node and that node without crossing the space in between. In other words, they disappear from the known universe and reappear in the known universe over there. Yeah. Like I said, subatomic particles are kind of weird.
I was like, oh, well, maybe they just go around.
No, they don't go around. They go from here and they're there, but they disappear in between. There's nothing. When they're here and they're there, they don't actually disappear completely. They're either here or they're there. Yep. All right. So I want you to draw. I want you listen. I want you to make sure you have a drawing of your 2p orbitals that you made with balloons. Your drawing of your balloons. So if you're going to color it, color the color of your balloons. Okay? And then also I want you to draw a separate drawing that shows those 2p orbitals inside the 2s sublevel of orbital.
Whoa, Mr. Taylor.
Okay?
Wait, go back. Let me see what the other one was like. You just don't have time around it. That's what you want. You look the same to me. Are you asking me?
There's the nucleus. All right, 2s, the nucleus, 1s sublevel, two p orbitals, two s orbitals, and the actual shape of those p orbitals looks like that. This is what the p orbitals actually look like. Well, I shouldn't say actually, because I'm not really drawing what they actually look like, because they're really clouds. Okay, and they're really probabilities. So you can't really show probabilities as a drawing.